Hey there! Today we are going to solve another LeetCode problem named generate parentheses. A medium level, and it goes like this. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. There are some examples here. So if n is equal to 3, then we would have 5 combinations of these well-formed opening and closing brackets. I would refer to them as just openings and closings. And if n is equal to 1, then we have one single string option. It's an opening followed by the closing. And according to constraints, n stays somewhere between 1 and 8. All right, so let's start to work on our issue by introducing the result variable, an empty array of strings, which we are going to fill and return at the end. Now, let's think on how we are going to generate those strings step by step. First, we are able to put only the opening to the string, and there is no any other option. At the second step, we have next cases. First of all, we are able to extend this opening with another opening, but only in case if n is greater than 1. Because n is a given amount of pairs of brackets, 2 brackets for a single pair, that would be too many. And another case, we could put a closing bracket over there, and that's it. At the third step, we are able to extend our couple of openings with the third opening, but only in case if n is greater than 2. Alternatively, we are able to put a closing bracket there, and in our third case, we are able to extend our couple of opening and closing with another opening. But again, only if n is greater than 1. So as you see, we've started from one string, and step by step the amount of combinations grew like a tree. And that's why I would like to solve this issue using some kind of recursion. So we are going to try to modify the initial string, an empty string. At each step of the recursion, we are going to either put an opening or a closing at the end. And whenever the string is ready, we would put it to the result. So let's create this method, let's name it as generate. We are going to need our result as an in-out argument, so that we would be able to append our strings to the result if needed. And of course, we are going to need the current string status. So initially it's going to be an empty string, and we would modify it in this recursion. All right. So let's check for the first option. When we are able to put an opening to the string. So at the first step, it was our only option. At the second step, we are able to do this if n is greater than 1. In the third step, we are able to extend 2 openings with the third one if n is greater than 2, or we are able to extend a couple of opening and closing with that if n is greater than 1. Basically, the maximum amount of openings in the string is n, and whenever we are adding a new one, we are reducing the amount of openings which we can use in the string on the next steps. So let's compare this amount of openings in current string to n. So for that, of course, we are going to need an n as an argument. And also we are able, of course, to calculate this amount of openings from the string itself, but I would prefer to just have it as an argument. And all right, now we could check if the amount of openings is less than n, and if so, then we are able to proceed to the next step of the recursion. So we are going to provide a result. As for the current string, we are going to extend it with an opening. The amount of opens is going to be increased by 1, and the n is going to stay the same. Nice. So what about the second case, when we are able to extend the string with a closing? So in the first step, we are not able to do it at all. We don't have any openings standing first to add any closing. At the second step, we are able to do it as an option, and at the third step, we are able to extend two openings with the closing, but we are not able to put it after a couple of opening and closing. Basically, we are able to put a closing to a string only if there is enough openings in it at the moment. So let's provide another argument in this function. So it's going to be closes, and if amount of closings is less than amount of openings, then we are able to extend our string with the closing. In this case, the amount of openings would stay the same, but the amount of closes is going to be increased by 1. Now we just need to modify our previous call of this method. So in this case, we don't modify the amount of closings. Great. So now we have our recursion in place, but we need to finish it at some point. So at some step of the recursion, the current string would be good enough to be put to the result without any modifications. So when is going to happen? Of course, the amount of openings and the amount of closes are going to be equal, and they both are going to be equal to n. In this case, we are able to just append our current string to the result and return from the method immediately. We could simplify this check a little bit, because as you can see, when we modify these strings, first we modify the amount of openings. So they would reach the amount of pairs, the n, first, and only then the closes would catch up. So we could remove the first check and just check that there are enough closings in the string. Finally, let's call the generate method from our main one. So the current string is going to be an empty string. The amount of openings is going to be equal to 0. The amount of closes is also going to be 0, and n we would provide as is. Nice. Let's check the code for any compilation issues. Nothing over here. And finally, let's submit the solution. Great. So as you can see, the execution time of this solution stays somewhere on the edge of the threshold. That's why it is executed in almost 0 millisecond, and it beats 100% of other submissions. And that's it for today. If you'd like to see me solving other LeetCode problems, then put your requests to the comment sections. See you next time. Cheers.